You got A and master and you guys,
Yes.
Okay, so let's check these homework problems and see what we need to talk about, what we need to go over. Number one, the only one that was not coterminal was 450. What does coterminal mean? Stops rotating at the same location. Okay, check 2A and 2, let's do one at a time there. Zoomed in a little too much. So check 2A. Where do we always make the perpendicular with? When we make these little triangles. Perpendicular is always with the x-axis. And theta is always that angle up near the origin. Any questions on 2A? Okay, any questions on 2B? Okay. 3A. So this is called a Pythagorean triple. When you have these nice integers that form a Pythagorean or fit the Pythagorean theorem. And so 3, 4, 5 is the smallest of those. What's another one? 8, 10. Remember, what's another one off the tip of my tongue? Anyway, 3, 4, 5, you see a lot because they're the smallest, neatest little integers that fit the Pythagorean theorem. So be on the lookout for 3, 4, 5. They will pop up from time to time because they're such simple examples to use. Okay, so part B, we got into some undefined values because we ended up having a 0 in the denominator. So when that happens, our answer is just undefined. Question on that?
One, I did a triangle, but not very.
Number one, okay. Does someone want to share what they did for number one? Nobody? Okay, what I would do is probably take the ones that were larger than 360, and I would find, so how do we do that? Subtract 360 from it. So I would say, all right, 510 minus 360 gives me 150. That means those two are definitely coterminal, so neither one of those are my answer. Okay, negative 210, to test that one, I don't want to subtract 360. I want to add 360. Because I want to get a positive number, and that also gives me 150. So all three of these are coterminal. Okay, if I take 450 and subtract 360, which is just one full rotation, that gives me 90. And then this one, I believe you just have to subtract 360 twice. And you'll get the 150 as well. Okay? You're welcome. Anything else on page 1? Okay, second page. Let's see, I think we can get all 4 of those in there. A, B, D, and E, see what you have a question on. Notice that every single one of these, I am drawing a picture. Some of you did not draw pictures. We're not just typing it in our calculator unless you want to do that to check it. Like on a quiz or a test, I am looking for the triangles. And if they are not there, then I will count off. So we're looking for the whole concept, not just the answer. Usually the answer is the least important part, really. Like the process, the concepts, those are what I'm really interested in. So I'm drawing the right triangle. I'm making the perpendicular with the x-axis, and the angle that I'm dealing with, theta, is up there by the origin. Any question on those 4? Anybody question? I'm sure. Anybody? Okay. Then pick that C and F. C, yes. Okay, so what I did first is I took 23 pi over 6 and I converted to a degree to kind of wrap my brain around where this would be located. So I multiplied by 180 over pi Pi's cancel, and that gives me 690. Are you okay with that part? Okay. So I'll just kind of keep going then. So I did exactly what we did just a minute ago. I took 690 and I subtract 360, and that tells me 330. So that's pretty easy to figure out where it is. That puts it down in the fourth quadrant with 30 degrees left over here, perpendicular to the x-axis. 30 is the angle inside the triangle that I'm dealing with. So I'm using those ratios for 30, 60, 90. 1 is opposite, 2 is the hypotenuse, square root of 3 is opposite of 60. But I have to make that leg negative because of direction. I went down, fourth quadrant or y coordinates are negative. And then I can tell you what cosine is, which is adjacent over hypotenuse. So I really didn't even need that negative anyway. Any other questions on those? Okay, so then at the bottom, those were all quadrantal, which means they stop rotating on an axis, not in a quadrant at all. And that last answer there says undefined. Any questions? How do you find the radius on these? How do you find x and y for that matter? Pick any point on that axis. I use different ones. I use 0, -2, then -3, 0, then 0, 1. Any point that is on the axis will work. And then just based on your point, you'll know how far it is from the origin, which gives you the radius. Any questions? Okay, so how do we do? Thumbs up, thumbs down, somewhere in between. Okay. Are you sure you have no other questions? All right, then we are going to, before we actually make our unit circle, which you should be very excited about, I have a warm-up for us because we're going to be dealing with some fractions today. So I have 8 problems that are called complex fractions. What's a complex fraction? Not simple. Fractions within fractions. Okay, and we're going to simplify these 8 and then we'll go on with the lesson. Okay, all right, so let me come out of those. Let me pause my video here. And then voila, we'll have the answers in a minute. I feel like the start of a movie. 3, 2, 1. Okay, number 1, did you get that? Okay, so some of you are saying, I can't remember what goes on top and what goes on the bottom. If you forget, set up your normal keep change flip. So that's a 7/1 times 3/2. And then right away you'll see that, oh yeah, the 7 and the 3 go on top and the 2 and the 1 go on the bottom. Okay, so if you forget, just set it up once and then that should remind you. Okay, get that for the next one. 3/32. Hey, y'all, stop me if I need to elaborate on anything. Okay, this one got a little messy, didn't it? Check your answer. So I definitely want to think of that 1 as 1/1, and that ends up putting 2 over square root of 3, which means I need to rationalize it. So that's how we got that square root of 3 up on top and a plain old 3 on the bottom. Any questions? Okay, the next one. You get square root of 2/2. Really initially got 1 over square root of 2. But then we rationalize and get square root of 2/2. Good with that? I guess you can already see that answer out there. Can you leave it on 12? Yeah, if you don't reduce the 12 and the 30, it's not wrong. Questions on that one? Get most of them right? I see some people writing on this one. Are there any questions that I need to answer? Okay, please don't be shy. Oh, 6. Did anybody not even set this one up? Like you just looked at it and you realized, wait a minute, those are the same numbers. Any number divided by itself is 1. One of them is negative. Negative divided positive is a negative 1. Anybody realize that? Okay, so be on the lookout. Like it might be messy, but if you're dividing something by itself, it doesn't matter how messy it is, it's always going to be 1. All right, next, square root of 3, the 2's cancel.
Can you still keep it?
Hmm?
Can you still
You can still keep the 2. It wouldn't be wrong, it's just not simplified. It's like leaving 5/10 instead of 1/2. Not wrong. And last one, square root of 3 over wonky looking 30. Question. Do the last one. Okay. Rationalizing it. Okay, so I did very top times very bottom and I got 2. And then the middle 2 multiplied gave me 2 over square root of 3. How many of you went ahead and canceled the 2's? I know I saw some people doing that. Okay, so you could go ahead and cancel the 2's there. It might be a little bit simpler. But all I have to multiply by there is the square root of 3. Did you multiply by 2 square root of 3? It'll work also. So if I did that, 2 over 2 square root of 3, 2 square root of 3 will give me 4 square roots of 3 over 2 times 2 is 4. Square root of 3 times square root of 3 is 3. 4 times 3 is 12. And then that 4 and 12 reduced to the 1 and the 3. So you can still get there. Just a few more, or one more step maybe. And honestly, the quickest way is to go back here and go ahead and simplify the 2's, which gives me 1 over square root of 3, and then rationalize that. That's the quickest way to get to the answer. So 3 different ways of getting to the same thing. Any other questions? Okay, so how many of you truly did not touch your calculators and you did okay? Okay, so sometimes not using that calculator is quicker. And doesn't that feel good? Like, I did that all by myself. I didn't even touch that calculator. Okay, next part of the lesson. Go ahead and find for me these 2 triangles. Whether they're in your notes or on your formula sheet, go ahead and locate those. Okay, how many of you know these ratios already? Like they're locked away in your brain. Anybody? A couple people? Okay. Okay, so if I said just draw and label a 45, 45, 90 triangle, what should it look like? What would a 45, 45, 90 look like? Right triangle? Say that second part. Okay, what would be true about the 2 legs? They would be the same. I'm going to attempt to make it look like that. I don't know how well I will do. Don't know that I accomplished that, but we're going to pretend that those 2 legs are the same leg. Okay, so the ratio is x square root of 2. I'm just going to use the 1